A helicopter rises from rest on the ground vertically upwards with a constant acceleration g. A food packet is dropped from the helicopter when it is at a height h. The time taken by the packet to reach the ground is g is the acceleration due to gravity. To analyze the situation, let's define the variables involved. Let g be the acceleration due to gravity. The helicopter rises with a constant acceleration g. Let h be the height at which the packet is dropped. Step 1. Determine the velocity of the helicopter when the packet is dropped. Since the helicopter starts from rest and accelerates at g, the velocity of the helicopter when it reaches height h can be calculated using the equation of motion, v is equal to u plus a into t, where u is equal to 0, initial velocity, a is equal to g, acceleration, t is the time taken to reach height h. The distance covered by the helicopter in time t is given by h is equal to u t plus half a t square. There h is equal to half gt square. From this equation, we can solve for t. T is equal to square root of 2g by h. Step 2. Find the velocity at height h now. Substituting t into the velocity equation, v is equal to gt, therefore v is equal to square root of 2gh. Step 3. Analyze the motion of the food packet after it is dropped. When the packet is dropped, it has an initial upward velocity of v is equal to square root of 2gh. After being dropped, it experiences the acceleration due to gravity minus g, downward. Using the equation of motion for the packet, we have s is equal to ut plus half a t square. Setting s as the distance it falls, which will be h, and substituting a is equal to minus g and v is equal to square root of 2gh. Minus h is equal to square root of 2gh into t minus half gt square. Step 4. Solve for time t. Rearranging gives half gt square minus square root of 2gh into t minus h is equal to 0. This is a quadratic equation in t. Using the quadratic formula, t is equal to minus b plus or minus into square root of b square minus 4ac by 2a. We know that a is equal to g by 2, b is equal to minus square root of 2gh, c is equal to minus h. Plugging in the values, t is equal to root 2h by g. Conclusion. Since the negative solution doesn't apply, time can't be negative, we have t is equal to square root of 2g by h. This shows that the time depends on the height h from which the packet is dropped and is inversely proportional to the square root of the gravitational acceleration g.